Alright, so we made it on to the next level here. Our next step is selecting the cloud service provider and also for management purposes, for managing your IoT device. If you're deploying hundreds of thousands of IoT devices, then you don't really want to do a lot of the steps that you would do if you're building one or two or even 100. You want to automate most of the processes or steps that you would do. For example, naming schemes, naming each device. What will it call itself? What will it be assembled as? Next would be credentials. What is its credentials? Like authenticating these devices, making sure that they're a real device and not some malicious activity that could act as a device to try to gain access to the network. So building IoT devices, you always have to think about scaling. In how would you make sure that these devices are going to be designed in a way that they're capable to be scaled, that your whole process is to be able to be scaled. IoT is not just about building a device. IoT is about building a whole structure. If your structure is strong enough, if your architecture is strong enough, you're going to be able to handle many different devices, many different sensors. Selecting your cloud is very important because your cloud service provider is going to be the one that will help you expedite your process, will help you jump from just being a one device or two devices to hundreds of thousands of devices in no time. So selecting a very good cloud service provider that has experience working with IoT specifically and has built an IoT infrastructure is the most important, crucial part of this whole structure, right? You want to spend a lot of time reading and understanding their sample codes. And when I say sample codes, I don't think that you should spend a lot of time reading their documents, their development documents, because I mean every single cloud service provider is going to have their own hundreds of pages of documents that they can explain hundreds of different things that might not even apply to you. So you shouldn't be reading the whole document just maybe read about the structure as an overall, to just get an idea of the whole picture, but not read the whole document. So what I recommend you do is try out the sample codes. Try to connect that module that you already built, that you have the connection, the communication protocol set up. You have your microcontroller and you have your sensor. So you have all three that are necessary to communicate back with any cloud service provider. So figure out how these guys are going to communicate with your specific cloud service provider that you've chosen. Once you have that communication pipeline opened up, ready to go, you're pretty much set and ready to go for the next step. And really, your whole IoT infrastructure should be good to go because you've set up that pipeline. It should be secure. You should definitely make sure and spend a lot of time on security. There's a lot of security protocols out there for IoT devices. You should definitely explore a lot of them, especially if your device is doing some physical action or a reaction per se. Is that, if it opens or closes a door, if it turns on and off a light switch or things like that. That's what hackers are looking for. They're not really looking for devices that collect data. They're looking for devices that have the ability to make some kind of action, take some kind of control. Say you got a contracting opportunity to where you need to install temperature sensors on a couple of machinery in a factory, and these temperature sensors need to be able to report back the temperature for the machine and let the cloud or the server know that this machine is its current temperature at discrete levels, like maybe every minute, every hour. And so when you get those data points out in the cloud, now you have to do some work on it. You have your application is just going to be next. What you need to be doing is, okay, so all these data points are coming in. You need to make sure that there's a space out, that you're storing all these data and you're running an analysis on them. There are such things as just-in-time analysis, just-in-time calculations, things where as soon as the data point arrives into the server, that it does some quick calculation on it and then sends it out to the right direction. Say if it needs to create an event. So if the temperature has reached a certain threshold, or if the temperature is starting to go a little by little higher and higher upwards, that could also indicate that, hey, in the past, this has indicated that the sensors actually, or the machine is actually might be damaged, or something's going on, that something's wrong with the machine that's causing its temperature to slowly go up. So we need to have somebody out and take a look at it real quick. So what do you want to do? You want the server to quickly analyze that and quickly find that out. And then once it finds that out, it will quickly send a message out to the engineer or the maintenance people on the floor, letting them know, hey, machine number 65 or whatever is overheating. It's indicating some overheat. We're going to go ahead and turn it off. So the server will automatically send another message out to another IoT device that's possibly connected to the power switch of the machine to let it know, hey, shut it off because that machine is overheating. And so that's how it will, that's how machine-to-machine communication really works at its best, is if the whole action-reaction is all automated, being proactive.